So in lesson 2, we'll be covering how EMI is measured using a LISN. So EMI is measured using a LISN plus a spectrum analyzer with a common mode / differential mode separation. As we can see in the image here, what we have as a device under test, which is set up on a table that is electrically insulated, and then it's connected to a LISN, and the LISN is connected to a spectrum analyzer through a cable that has an attenuator and a transient limiter. On the other hand, the LISN is connected to the mains through this cable. So what does a LISN do? A LISN creates a defined RF source / load impedance and a measurement port. A 50 ohms at frequencies above 150 kHz. It isolates the DUT from the mains at RF level, okay? Or we're talking 150 kHz and above level. It prevents the backfeed of noise into the power network, and it prevents the flow of mains noise into the DUT for an accurate emissions measurement. See, the problem with not using a LISN is that some grids, they might have a different impedance than others, and also some grids in some countries or in some areas might introduce some noise onto that, the device that you're testing. So to create a uniform way and a fair way, I should say, of testing equipment, LISNs were developed. So what are the LISN defining standards? Different applications are governed by different standards. For example, vehicle / boat components and onboard systems or onboard chargers are governed by CISPR 25. For these components, CISPR 25 dictates that a 5 microhenry LISN should be used to measure EMI. On the other hand, components that are in direct contact with the AC mains, for example, off-board EVSEs, these are governed under different standards like CISPR 16, CISPR 11, CISPR 32, and these standards dictate that a 50 microhenry LISN should be used to measure EMI. What we see here is a 50 microhenry LISN per CISPR 16 2014. A 50 microhenry LISN means that there is literally a 50 microhenries installed in that LISN. Compared to, for example, a 5 microhenry LISN, where that 50 microhenries is replaced with a 5 microhenries. But in this case, the LISN would not be in contact with mains. So going back to this one, the 50 microhenry LISN is meant to be in contact with mains, the AC mains, and on the other side, it gets in contact with device under test. So these components constitute the 50 microhenry LISN. We have a 1 microfarad capacitor on this side. We have a 50 microhenry LISN. We have a 0.1 microfarad capacitor, a 1 kilo ohm resistor, and a 50 ohm resistor. This 50 ohm resistor here is basically the measurement port. Now, the point of having 50 microhenries here is to basically, emulate the impedance of the power lines. And the higher inductance that we have here compared to the DC case, the 5 microhenry case, is meant to basically provide a 50 ohms right from 150 kilohertz and above. On the other side, in this case, we don't really get 50 ohms right from 150 kilohertz and above, but we start to get 50 ohms perhaps around 450 or 500 kilohertz and above. That's because of the smaller inductance that we have here. So how are some of the measurement limits being specified by the standards? If we take CISPR 25, for example, CISPR 25 has separate limit tables by method for voltage and for current. So whether you are measuring EMI using the voltage method or the current method that we spoke about earlier, there are tables in CISPR 25 that govern that. In addition, by class, for example, from class 1 to class 5. These class numbers are basically an agreement that happened between the supplier and the OEM on basically how strict the EMI limits should be for a certain equipment or for a certain system. In addition, low voltage and high voltage supply systems have different LISN setups and limits. In the next lesson, we'll cover how common mode and differential mode measurements are done in a lab.